Hello, welcome to Unlock the Value of Systems Center and Azure Pack webinar. My name is Simon Skinner. I'm a Systems Center MVP. You can follow me on my Twitter handle, which is Simon Skinner, spelled C-Y-M-O-N, or alternatively on my email address, simon@skinner.fr. Please feel free to follow me or contact me after this webinar. So let's continue. We're going to be talking about the fabric of System Center. So what we will cover will be the fabric components overview, host groups, library servers, optimization, fabric networking, and storage. So just as a quick summary, this is made up of compute. So you deploy your compute resources, taking them from bare metal to fully deployed for your physical and virtualization hosts. We have storage, so discover and classify and allocate storage for the use of the private cloud. Provide the correct storage for use with the appropriate access. A network, abstract your complex networking infrastructure into logical networks for cloud use. Assign IPs, virtual IPs, and MACs addresses from pools and integrate with load balancers. With clusters, consolidate your fabric elements for use in a private cloud. Library, organize your VM templates and files on a centralized repository. WS servers, WSUS servers, keep your virtualization hosts up to date based on the customized and compliance profiles. Host groups, separate your virtualization hosts onto different folders and apply different placement rules, restrictions, network configurations, or storage connections. And finally, Pixie servers. Add Pixie servers to your fabric to set up your Hyper-V virtualization hosts using bare metal deployment. So we'll start off by talking about host groups. So you can use host groups to group virtual machines in a meaningful way. For example, based on a physical site location, hardware capabilities or type, the level of redundancy, deployed services or server role, hypervisory type, business unit or delegated model. When you design a host group structure, consider the following. Settings and resources are assigned at a host group level, such as a custom placement rules, host reserve for settings placement, dynamic optimization and power optimization settings, network resource inheritance, host group storage allocation, and custom properties. By default, the child host group inherits the settings from the parent host. You can assign host groups to a delegated administrator and a read-only administrator user roles to scope the user for a specific host group. Members of these user roles can view, manage the fabric resources that are assigned to them at a group host level. You can provide a private cloud for resources within a host group. So when you create a private cloud, you select which host groups will be part of the private cloud. You can then allocate them some resources that you have selected for the host groups to the private cloud. So just grouping isn't just about putting it into a logical folder, but you can actually make different configurations based on many different factors. So to configure the group configuration, if we just have a look at this, the host groups can be created using two different methods within the console. Open the Fabric workspace, and then on one of the following groups, you can right click and then you can create a host group, as you can see that in our image. Or in the folder tab, select the host, then create a host group up on the actual menu itself. After the host groups have been created, they can be restructured either by dragging to the host group or to a new location in the host structure, or by using the Move option. To make the Move option visible, you just right click on a host and you'll be able to use the Move button. Also in the ribbon at the top to select the host group. Host groups can be generally created using PowerShell also. General settings for the host groups are used to configure the host group name. It's in this location that the host group hierarchy and the description. The location of the host group hierarchy can be adjusted by using the Move button to allow the unencrypted file transfer. Determines if the transfer to and from the library should be encrypted. By default, only encrypted transfers are allowed. VMM automatically identifies the most suitable host to which you can deploy your virtual machines. However, you can specify custom placement rules. By default, a host group uses the placement from the parent host group. Placement rules allows SCVMM 2012 R2 administrators to define what conditions an object should comply to be placed into a specific host. Custom properties, objects like VMs or templates should match or be different than the host custom properties. Custom properties allow you to capture any additional information that is most common with VMM objects, host, virtual machines, host groups, clusters, services, clouds, etc. It just allows you to store your own tags such as a cost center, contact email addresses, or physical locations. They are free text strings and they show up when you view in the properties of any of those objects. VMM automatically creates blank custom properties, custom 1 through to 10, but you can create your own. You can do this by going to the properties of any VMM object. Click the Custom Properties tab, then click Manage Custom Properties. Then you can create a new one such as Possible Hosts and assign it to any of the object types it applies to. Create possible hosts, then assign it to both host and VM objects. Use the drop down at the top to choose the host and the VMs. And for each one, use the Add button to assign the property to both objects. You will now be able to see the host and you can place each of your VM's custom placement rules allow you to enforce about what the VM should be placed on what host based on the custom rules. Host reserve settings specify the amount of resources that a virtual machine manager sets aside for the host operating system to use. For a virtual machine to be placed on a host, the host must be able to meet the virtual machine's resource requirements without using the host reserves. Host reserves will not inherit from the parent if we uncheck the option. As we can see in this diagram, use the host reserve setting from the parent host group. You can set host reserves for individual host groups or individual hosts. The host reserve settings are for the root host group. All hosts are set to the default host reserves. So we can add to the following resources that can be configured for reserves like CPU, memory, disk I/O, disk space, or network I/O. Network reserves ensure that it's not possible to place a new VM on a host that will violate the host resource reservation. This allows administrators to guarantee the minimum resources on a host are always blocked. Administrators can define their own reserve based on specific needs. So we can define our host groups, so we can define our resources. Host group dynamic and power optimization. What is and why use dynamic optimization? As application workloads change, I need my private cloud to change resources utilization accordingly. For example, at the end of my quarter, my finance application needs more resources, but at other times it's mostly idle. I need to ensure all applications get the resources they need and when they need them, and I can't watch this all the time. If I'm not using resources that I don't want to waste the energy to run the infrastructure. I want to only power on what I need. Dynamic and power optimizations The fundamentals are for live migration, manage resource, options, or user-defined schedule. So with live migration, we can keep our clusters balanced, avoids VM downtime, and supports heterogeneous clusters. In VMM, we've kept the host reserve feature and augmented it to provide new levels of configuration. Dynamic optimization, also known as DO levels, and power optimization levels. As with the host reserves, the thresholds can be set for CPU, memory, disk I/O, network I/O. So Microsoft have provided sensible defaults for all of these settings that the users can then go and apply their own individual settings according to their environment. So if we look at this example, we can see that currently all the hosts are running correctly, as indicated by the green performance monitor at the bottom right-hand corner of each host. But as the resource utilization changes, we can see that one of the hosts on the left-hand side has in fact gone above the optimization threshold. So what VMM does is it starts to move the virtual machines around for us automatically based on our rules. So we're always running at the optimal way for the hosts. So again, everything is now running optimally, but if that changes and it goes above the optimization threshold, SCVMM will automatically rectify that for us, always ensuring that the VMs and the hosts run as optimal as possible. If you're dealing with large environments with lots of hosts, this is a very, very cool feature for you to be able to use. Let's just have a look at how that looks within SCVMM. So during the dynamic optimization, VMM migrates virtual machines within a host to improve the load balancing among hosts and to correct any placement constraints or violations of the virtual machines. Dynamic optimization can be configured on a host group to migrate machines within host clusters within a special frequency and aggressiveness. Aggressiveness determines the amount of load imbalance that is required to initiate a migration during dynamic optimization. By default, virtual machines are migrated every 10 minutes with a medium aggressiveness. When configuring frequency and aggressiveness for dynamic optimization, an administrator should factor in the resources cost of the additional migrations against the advantages of balancing the load amongst the hosts in the host cluster. By default, a host group inherits the dynamic optimizations from its parent. Dynamic optimization can be set up for clusters with 2 or more nodes. If a host group constraints standalone hosts or clusters do not support live migration, dynamic optimization is not performed on those hosts. Any hosts that are in maintenance mode are also excluded from dynamic optimization. In addition, VMM only migrates highly available virtual machines that use shared storage. If a host cluster contains virtual machines that are not highly available, those machines are not migrated during optimization. On-demand dynamic optimization is available for individual host clusters using the optimized host actions in the VMM and services workspace. On-demand optimization can be performed without configuring virtual machines that can be without configuring the host group. After dynamic optimization is requested for a host group, the VMM lists the virtual machines that will be migrated for the administrator's approval. Dynamic optimizations will not inherit if we uncheck the option for the dynamic optimization. And again, we can use PowerShell to set this aggressiveness. The power optimizations is an optional feature within dynamic optimization. It is the only available when the host group is configured to migrate the virtual machines through dynamic optimization. Through the power optimization, VMM helps to save energy by turning off hosts that are not needed to meet the resource requirements within the cluster, and turns off the host on or off if they are needed. Now, to be able to complete this, you need to have a BMC card, which is required, which is the only way to be able to turn the hosts on and off. By default, VMM performs power optimizations all of the time when the feature is turned on. However, you can schedule the hours or the days of the week when the power optimization is performed. For example, you might initially schedule power optimization only on the weekends when you anticipate that the low resource usage for your host. After observing the effects of the power optimization in your environment, you may increase those hours. Power optimization ensures that the cluster maintains a quorum if the active node fails. For clusters created outside of VMM and added into VMM, power optimization requires a furthermore 4 hosts. For each additional 1 or 2 nodes cluster, only 1 node could be powered down. So for example, if you have one node can be powered down if you have 5 or 6 nodes, or 2 nodes if you have a cluster of 7 or 8 nodes, or 3 nodes if you have 9 or 10. When VMM creates a cluster, it creates a quorum which uses that disk as part of the quorum model. For clusters created by VMM, power optimization could be set for clusters for 2 or 3 models. So host group network resources. Host groups will contain virtualization hosts that will access the network resources on the fabric. We can pre-assign the network resources like IP pools, MAC pools, load balancers, logical networks, and the host groups, so we can leave it empty and assign those later if we wish. In fact, each of these resources we will ask what host groups you want to assign while you create the objects. Host group storage resources allocations. The servers of the group hosts have been connected to shared storage within fiber optics or an ISCSI. The storage provider must be added to the fabric before being able to allocate any storage. SCVMM 2012 R2 does not mask or unmask the LUNs at the storage level. Hyper-V hosts in the host group will be able to connect or create to new LUNs or rapid provisioning using SAN cloning or a snapshot. Or again, we can use PowerShell to do this if need be. So just briefly, when we have the configuration for our custom settings, again, it's free text, so we can add in our own custom and then make that available against our host groups for them to be able to match those criteria. Adding Hyper-V host to SCVMM. This is done quite simply by the wizard. So we can, when we want to bring in a machine, we've got a choice. We can have an existing Hyper-V or hosts Hyper-V from host clusters, create or add new Hyper-V hosts or new clusters, bare metal deployment for computers without OS installed, domain joined perimeter network, or an untrusted AD computer. So we have enough methods for us to incorporate our hosts that should be able to deal with most requirements for networking, for networks. So library servers. For our library servers, the virtual machine library contains the building blocks used to support a variety of operations in Virtual Machine Manager. The library contains more than a collection of file-based resources. A virtual machine manager consists of entries stored in the virtual machine database and library servers that shared folders and resources. For example, templates and profiles, equivalent objects. If you don't know what an equivalent objects are, they're a group of library resources that tell SCVMM to consider that they're their own subject. This aims having more than one copy or more than two copies or one copy of the same thing. So it's kind of like a dedupe thing. We also have cloud libraries in our library servers, self-service user content, stored virtual machines and services, or the update catalog and baselines. The library servers can be supported on Windows 2012 or both flavors, or a Windows 2008 R2 Service Pack 1 machine. Highly available library shares are able to be configured, and equivalent objects are the resources that you can use them replicated by using replicate technology that you would normally use or be able to copy from each location. Library servers can be in the same domain or in a trusted domain. Firewalls, though, must allow for SMB traffic between the SCVMM server before they can use a library server. Additional shares must exist before adding them to SCVMM. And don't create additional HA share for an SCVMM cluster, as this isn't actually supported. So again, the library servers, we can have them allocated to our host groups. So each host group, we can say that can take certain resources from our library servers. So now let's cover Fabric updates. So to use WSUS, we can use it with Windows 2012 or an earlier version in Windows 2008. So it's the same configuration as we use for WSUS. But we can install it on a separate computer is the preferred method. But WSUS are part of the environments that are supported. But you need to have the WSUS console installed on the VMM machine. So actually what happens is that WSUS will ensure that the hosts are fully updated, but because the mechanism is within SCVMM, when a machine needs to be updated, it will automatically move the VMs across to available hosts to ensure that the VMs are not disrupted whilst the host is being updated. Now let's have a look at SCVMM 2012 Fabric Managing Networking. Site-to-site network virtualization uses generic routing encapsulation, which is MVGRE. Windows Server 2012 R2 delivers new functionality for site-to-site gateways and Hyper-V network virtualization. By using all Microsoft software, this functionality enables host providers of virtualized networks to achieve a higher capacity and better reliability and enable the majority of the tenant scenarios. Support includes multiple site-to-site tunnels and direct internet access through the Network Address Translation, or NAT. Tenants can use preferred IP addressing for all of their virtual machines, in multiple sites and in the cloud. All supported by Windows 2012 R2 and SCVMM. MVGRV support, because the VMM APIs are more flexible, network services such as load balancers can function as network virtualization gateways, and switch extensions can use network virtualization policy to interpret all IP addressing information in packets that are sent. Communication between commonly used Cisco switches extensions and VMM is expanded through support for using these switches extensions with Hyper-V network virtualization. It is possible to use IP addressing management or IPAM within SCVMM, which is a functionality of Windows 2012. IP address management for virtual machines and hosting providers and enterprises can be more easily managed via the virtual machines across data centers. After virtual machine deployment, you can view the IP addresses for each network adapter and you can change or add IP addresses without logging onto the virtual machines. For a virtual machine migration, you can assign a new IP or from the IP pool in the destination subnet. In addition, virtual machines in a guest cluster can set their own IPs on a network that use Hyper-V network virtualization. Let's have a look at the SCVM 2012 R2 network objects. So we have logical networks, address pools, and load balancers. With the logical networks, we can classify networks for VMs to access, map to network topology, and allocate to hosts and to clouds. Address pools allocate from a static IP address to VM for prefigured pools. Create IP pools as managed range of IP address assignment, and create MAC addresses as a managed range of MAC address managed address assignment. Load balancers apply settings for a load balancer capability within a service deployment. Control load balancers through your vendor provider based on PowerShell, and create IP templates consistent of load balancer configurations and settings. So let's have a look at the logical network types. Logical network, together with one or more association network sites, is user-defined named grouping of IP subnets, VLANs, or IP subnets, VLAN pairs that are used to organize and simplify network assignments. Some possibles include back-end, front-end, lab, management, or backup. Because logical networks represent an abstraction of an underlying physical network infrastructure, they enable you to model the network based on the business needs and connectivity properties. After you've created a logical network, you can use it to specify the network on which to deploy the host or virtual machines, standalone or part of a service. Users can assign logical networks as part of a machine and service creation without having to understand the network details. You can use logical networks to describe networks for different or with different purposes, to create traffic isolation, and to provision networks for different types of service level agreements, SLAs. For example, for a tiered application, you can group IP subnet and VLANs that are used for the front-end web server tier as front-end logical network. You can group the IP subnets and VLANs that would be used for the back-ends, such as an application database, as back-end. And when the self-service user model and tiered application as a service, they can easily pick the logical network that that virtual machine in each tier of the service should connect to. At least one logical network must exist for you to deploy virtual machines and services. By default, when you add a Hyper-V host to VMM management, VMM automatically creates a logical host that matches the first DNS suffix label of a connection specified DNS suffix for each host adapter. When you create a logical host, you can create one or more associated network sites. A network site associates one or more subnets, VLAN subnets, or VLAN pairs with a logical network. It also enables you to define the host groups of which the network is available. For example, if you have Seattle host group, New York host group, and you want to make the back-end logical network available to each, you can create two network sites for the back-end logical network. You can then scope one network site to the Seattle group and any other desired child host groups, and you can scope the other networks to the New York host group, and again with any other desired host groups, adding the appropriate subnets of VLANs for each location. If you're running System Center 2012 and your network configurations will include VM networks that you can use for network virtualization, create at least one network site and associate at least one IP subnet with that site. You can also assign VLANs to that network site as appropriate. Creating a network site with an IP subnet makes it possible to create an IP address pool for the logical networks, which is necessary for network virtualization. If your network configuration will not include virtual machine networks, then use network virtualization. You can use other guidelines which are possible for configuration around 2012 System Center. So as we can see here with our network types, we have no isolation, isolation with VLANs, isolation with PVLANs, network virtualization, and we can have various different combinations of how we actually want to lay out our VLANs and our logical networks. Again, as you'll see throughout the whole of SCVMM, PowerShell is everywhere. So we can use PowerShell to create a logical network. Sometimes it's easier to use PowerShell because we can lay it out and understand exactly what our subnet is all in one place, whereas when we do it through the GUID, sometimes we're going on to different screens and we can easily forget what we've written prior. So let's have a look at address pool types. If you associate one or more IP subnets with a network site, you can create static IP address pools for those subnets. Static IP pools make it possible for VMM to automatically allocate static IP addresses to Windows-based virtual machines that are running on any managed Hyper-V, VMware, ESX, or Citrix or Xen server host. VMM can automatically assign static IP addresses from the pool to standalone virtual machines, to machines that are deployed as part of a service, and to physical machines that when you use VMM deploy them as Hyper-V hosts. Additionally, when you create a static IP address pool, you can define a reserved range of IPs that can be assigned to load balancers as virtual VIPs or virtual IP addresses. VMM automatically assigns a virtual IP address to a load balancer during the deployment of a load balance service tier. When you create a static IP address pool, you can configure associated information such as default gateways, domain name, DNS, or the DNS suffixes, or even WINs. For all of these settings are optional. IP address pools support both IPv4 and IPv6 addresses. However, you cannot mix the two up in the same IP address pool. Network virtualization. If your network configuration includes VM networks that use network virtualization, you must create an IP address pool for both the logical network that provides the foundations for those VMs and on other VM networks themselves. If the virtual machines on the VM networks are configured to use DHCP, VMM will respond to the DHCP request with an address from the IP address pool. For VLAN-based configurations, if you're using VLAN-based configuration, you can either use DHCP if available, or address pools. VMM that gives you direct access to the logical network with no isolation. If you have a virtual machine network that gives you access to an underlying logical network, you can use either DHCP if it is available, or an IP address pool for that network. Again, we can see that we can do this within PowerShell. And here's a further example of how we can allocate IP pool queries. So the load balancer support. Networking in Virtual Machine Manager includes load balancing integration so that you can automatically provision load balancers for your virtual environment. Load balancer integration works together with other network enhancements within VMM. By adding a load balancer to VMM, you can load balance requests to the virtual machines to make up a service tier. You can also use Microsoft Network Load Balancing, or NLB, or any other supported hardware load balancers through the VMM console. Network load balancing is included as an available network load balancer when you install SCVMM. So the VM network types. With SCVMM, you can configure your VM networks on top of your logical networks to make use of the network virtualization or other network configurations. Network virtualization extends the concept of server virtualization and allows you to deploy multiple virtual machines or VM networks on the same physical network. Virtual machine network that gives you direct access to the logical name without isolation. This is the simplest configuration, where the VM network is on the same logical network that is configured. This configuration is appropriate for a network that you will manage with a host. The VM network provides that the only functionality of the logical switch was introduced in System Center 2012. For this configuration, create a logical network and then create a VM network that specifies that logical network with a setting of no isolation. The VM network will then function as a logical network with no isolation networks within it. VMM-based configurations, if you're working with networks that use familiar virtual local area network or VLAN technology, for this network isolation, you can use those networks as if they are using SCVMM to simply manage the process. We can see here in this slide where we configure our VLANs or our isolation networks. Standard virtualization switch configuration on host properties supports two types by SCVMM, internal and external. Currently, private switches won't be supported in SCVMM. It does not support converged networks or virtual network adapter ports either. Native uplink port profiles natively for virtual network adapters and port profiles. The native port profile for uplinks, also known as the uplink port profile, specifies which logical networks you can connect to through a particular physical network adapter. After you create an uplink port profile, you can add it to a logical switch, which places it into a list of profiles that are available through that logical switch. When you apply a logical switch to a network adapter in a host, the uplink port profile is available in the list of profiles, but it is not applied to that network adapter until you have selected it from the list. This helps you create consistency in the configurations of the network adapters across multiple hosts. But it also enables you to configure each network adapter according to your specific requirements. To enable teaming of multiple network adapters, you can apply the same logical switch and uplink port profile to those networks and configure appropriate settings in the logical switch and uplink profile port. In the logical switch for the uplink mode, select Team and enable teaming. In the uplink port profile, select the appropriate load balancer algorithm and teaming model, or you can just use the default settings. Native ports for all virtual network adapters specifies the capabilities of those adapters and makes it possible for you to control how bandwidth is used on those adapters. The capabilities include offloading settings and security settings so they can meet up with the following capabilities. Enable virtual machine queue. Enable IPsec task offloading. For example, IPsec offloading requires the support from a physical network adapter and the guest operating system. Enables single root I/O virtualization offloading setting with a single root I/O virtualization, or SRIOV. A network adapter must be assigned directly to a virtual machine. To use the SRIOV, maximizes the network throughput while minimizing the network latency and minimize the CPU overhead, which is required to process the network traffic. So the logical switch. The logical switch brings port profiles, port classifications, and switch extensions together so you can apply them to multiple network adapters. Note that when you add an uplink port profile to a logical switch, this places the uplink port profile into the list of profiles that are available through that logical switch. When you apply the logical switch to the network adapter in a host, the uplink port profile is available in the list of profiles, but it is not applied to that network until you select it from the list. This helps you create consistency in the configurations of the network adapters across multiple hosts, but also makes it possible for you to configure each network adapter according to your specific requirements. To enable network teaming on multiple network adapters, you can apply the same logical switch upload port profile to those network adapters and configure appropriate settings within the logical switch and uplink port. Switch extensions, which you can install on the VMware management server and then are included in the logical switch, allow you to monitor your network traffic. Also allows you to use quality of service, or QoS, to control how much bandwidth is used, enhance the level of security, or otherwise expand the capabilities of the switch. 4 types of switches are supported in SCVMM. That's monitoring, capturing, filtering, and forward. So for monitoring, extensions can be used to monitor and report the network traffic, but they can't modify the packets. Capturing extensions can be used to inspect and sample traffic, but they can't modify the packets. Filtering extensions can be used to block, modify, or defragment packets. They can also block ports. And finally, forwarding extensions can be used to direct traffic by defining destinations, and that they can capture and filter traffic. To avoid conflicts, only one forwarding extension can be active on a logical switch. So the logical switch object relationship, as we can see in this example. On this slide, we can see the representation of the objects included in a logical switch and how they intersect with other SCVMM 2012 objects like virtual machine networks. This slide represents 2 Hyper-V hosts with 2 physical NICs. The first NIC is not connected to any virtual switches, but it is connected to the management logical network. This network can be the domain network from where the admin of the hosts from SCVMM. The second physical NIC or network adapter is both on the Hyper-V host are used by the SCVMM to apply the logical switch template that includes one uplink port profile that provides access to the production, cluster, and live migration logical networks. 2, the second, 2 virtual network adapter port profiles that create 2 virtual network adapters on each host to isolate the traffic and apply the bandwidth control. And 1 virtual network port that will be used by the VMs connected to the production VM network. This diagram assumes that production VM is connected to the production logical network, and the cluster VM network is connected to the cluster logical network. And virtual migration VM is connected to the live migration logical network. SCVMM network configuration workflow, as this diagram represents the logical steps that you may follow to configure your fabric network. The first step is to define what logical networks your fabric is using. These logical networks can contain the subnets of your physical network, the VLANs, and the IP pools that you want to use for static IPs to your VMs. Logical networks will be binded or linked to your host physical needs based on the segmentation that you are looking for. The second step is to create VM networks. The VM networks that are VMM network objects that you will use to assign your VMs or host to define the type of the connection and what subnets or VLANs. During the virtual machine provisioning or host deployments, we need to have the defined VM networks that we want to control and automate these provisions or deployments. Now, as we can see here, we've got our network cards and we've got our different VLANs and subnets configured through SCVMM. And on here we can see that we have a management logical network, converged logical networks, and client VMs. So network virtualization virtualizes the customer's IP addresses. So for example, it would be possible to have the blue corp and the red corp using the same IP subnets. From our data center, we have a host 1 and we have host 2. And for example, in blue, we're hosting Exchange on a subnet that is the same as red 1, who's also hosting Exchange. And on a different host, we have blue, which is on the same subnet as we have for red, also using the same application. So we can have in our clouds, if a client wants to use the same subnet as another client, that isn't going to represent a problem. But as we can see, the actual underlying IPs are not quite the same, but the host IPs are in the same subnet. So as we can see here, by using the same subnets is going to be taken care of inside the virtual networking of System Center. So it doesn't represent any kind of problems to our end clients that they can't use a particular subnet. Network virtualization gateway. Required if using network virtualization for isolation to provide access to the tenants or external network internet. To connect to virtual networks or other networks, you can configure the virtual network with a gateway. This configuration requires that the logical network on that VM uses it for a foundation. The network virtualization option, network virtualization gateway. To connect a VM to other networks, you can configure the virtual machine network with a gateway. This configuration requires that the logical network that the VM uses for its foundation, the network virtualization option, is selected. To configure a VM to connect to any other network within your environment, the gateway setting for the VM network selects the local networks. Alternatively, if you are a hoster and you want to allow your tenants, customers, clients to connect their virtual machines in the hosted environment that you provide to systems on their own premises, you can configure their virtual VM networks with gateways to configure a virtual machine network this way. For the gateways of the settings, select remote networks. This is a result of the connection through the private virtual network or VPN tunnel, as we can see that pictured here. And again here with the VM components. So we have the Windows Server computer on the VM server, and then that feeds into our different subnets within our configuration. Let's have a look at Hyper-V Extensible Switch. The Hyper-V Extensible Switch is a virtual Ethernet switch that runs in the management operating system of the Hyper-V parent partition. Starting with the Windows 2012 Hyper-V Virtual Network Manager, it can be used to create or configure or delete one or more extensible switches of the following types. An external extensible switch that supports ports that are connect to a single network adapter, as well as one or more virtual machines network adapters. This type of switch allows packets to be sent or to receive between all Hyper-V partitions and the physical network interface on that host. Also, applications and drivers that run in the management operating system can send or receive packets through this type of switch. An internal extensible switch that supports the ports that connects to one or more internal network adapters, as well as one or more virtual machine network adapters. This type of switch allows for packets to be sent or received between the Hyper-V parent partition to one or more Hyper-V child partitions on that host. Also, applications and drivers that run within the management group system can send or receive packets through this type of switch. A private extensible switch that supports ports can connect to one or more virtual machine network adapters. This type of switch allows packets to be sent or received only between Hyper-V child partitions. So VMM management of the switch extensions. With System Center 2012 R2, if you add a virtual machine switch extension to a virtual machine in Virtual Machine Manager, you can use a vendor network management console and the VMM management console together. You can use configuration settings or capabilities in the vendor network management console, also known as the management console for forwarding extension, and then use the console and the virtual machine management server in a coordinated way. To do this, you must first install the provider installed by the vendor on the virtual machine manager, and then you can connect the virtual switch extension to the manager within VMM. This will cause the VMM management server to connect to the vendor's network management database, import the network settings and capabilities from that database. As a result, you can also use those settings and capabilities. The Extension Manager integration. Within System Center 2012 R2, if you add a virtual switch extension manager to Virtual Machine Manager, you can also use the vendor network management console to serve together. You can configure the settings or capabilities in the vendor network and management console. This is also known as the forwarding extension. To do this, you first must again provide the provider installation. It's pretty much on the same configuration as on the screen that we saw just previously. So SCVMM supported storage for storage solutions and arrays. The changes on the storage provider since SCVMM R2, Microsoft supports targeted support for ISCSI and SMB3 support. SCVMM 2012 supported solutions for local block storage, remote block storage, and file server storage. As we can see in this table, there's quite a few supported storage arrays that are able to use within SCVMM. The changes on the storage provider since 2012 introduced the Windows Server to manage local and remote storage. SCVMM uses SMAPI for to manage our external storage. SMAPI supersedes the Virtual Disk Service of VDS. Also, thin provisioning a logic unit. The storage array must support thin provisioning. So adding Microsoft ISCSI target storage array to SCVMM server. The SMIS provider is a WMI based and passes the information onto the ISCSI target to service the storage management server on the SCVMM server. After being registered with SCVMM, a full discovery request is sent to retrieve all of the objects and their mappings from the SMIS provider. Storage volumes map to a WT disk or fixed virtual disk where the user creates an ISCSI disk using SCVMM. The SMIS provider uses a friendly name for the as the VHD name. If the virtual disk already exists during the SMIS discovery, the provider uses a description as the friendly name. If the virtual disk already exists but doesn't have a description or is empty, the virtual disk friendly name uses the prefix virtual disk index with an integer or an index of that afterwards. Adding Microsoft Target ISCSI target storage to an array, the SMI provider bases the same information and passes on the information to the ISCSI target to the storage management server. The masking set maps selects to the ISCSI target object. The friendly name of the masking set by default uses the prefix string of SPC with some sort of 16-bit random number after that. It is recommended to use a friendly name when creating the masking set, as VMM uses either the host name or the cluster name as its friendly name. Storage discovery. Administrators often have little visibility into the underlying storage infrastructure. Using System Center 2012 R2 Virtual Machine Manager, you can automatically discover local and remote storage, including storage arrays, pools, logical units, disk volumes, and virtual disks. You can classify the discovered storage by using friendly descriptive names to create and expose a simplified model storage. Storage provisioning within SCVMM 2012 can create new logical units from availability capacity provisioning to a Hyper-V host or a cluster. SCVMM 2012 rapid provisioning. As we're running out of time, I'm going to have to speed up a little bit, but rapid provisioning provides a method of deployment between two virtual machines to the storage arrays without the need to copying the virtual machine over the network. Virtual Machine Manager allows you to take advantage of your SAN infrastructure for cloning virtual machines combined with a VMM template for customizing the guest operating system. You can use rapid provisioning to deploy standalone virtual machines and virtual machines that are deployed as part of a service. As we can see here, the two main methods of rapid provisioning, a VHD that already exists on a destination path, or a LUN containing the VHD that is cloned and SAN transfers to the Hyper-V host. Microsoft ISCSI target provider has some limitations and some caveats. So clustered Microsoft ISCSI target in a failover cluster for ISCSI, the target server, you will need to register the storage device using the network name IP address for the resource group. Only one target per ISCSI cluster and only one SMI provider per server. SMB3 storage support is supported that for standalone clustered file servers, discovery of self-contained such as a NAS or a non-Windows creation of deletion of the file shares setting as the ACLs. But what's not supported is the deployment of file servers and clusters, configuration of block storage, load balancing, and SMB client connection, file share classification management of a single server with an ISCSI software through the SMIS provider, and file server roles. So this concludes our presentation today. I hope that we've got a good understanding now of the fabric of SCVMM, the fabric within System Center. Again, my name's Simon Skinner. You can contact me at simon@skinner.fr, or you can follow me on my Twitter handle, Simon Skinner. Thank you very much, and please take time to watch the other MVP sessions because they will also be detailing some very valuable information.